So in this video, we're just going to talk about solving equations in general. If you've come up through Algebra 1, Algebra 2, you solved linear equations that don't involve exponents, then you've solved equations that are quadratic equations that involve x squareds, but nothing above that, and then you progressively solve more and more difficult equations, and then by the time you're ready to take calculus, you have equations that might look like this that you're trying to solve. Now if you look at these directions and this particular set of problems that we're going to look at two of in this video, this particular set of problems comes from a calculus textbook, the preliminary chapter of that book, saying you should be able to do these things in order to have success with the ideas that are going to follow. The directions say to determine the number of real solutions, solve the intersection points exactly if possible, and estimate the points if necessary. So let's find the intersection points exactly in this first example. So if you're looking to find intersections exactly or solve an equation exactly, that means don't use the calculator. We're going to do it without the calculator initially, show how the calculator can help us after we've gotten the answers established by hand. So if we're trying to solve an equation, we're trying to get x by itself. Now the issue with getting x by itself here is you've got an x squared that's under a root, and you've got this x squared. I can't move this x squared over with this x squared because this is under a root and this one's not. What you cannot do, algebra doesn't allow you to, is it doesn't allow you to say the square root of x squared is x and then plus the square root of 4, which is 2. This definitely does not equal the original left side of this equation. So what we're going to have to do here in order to try to solve this by hand is get rid of the root right away by squaring each side. So if we square each side, the square root and the square do cancel with each other and we're left with x squared plus 4. Now on the other side here, you cannot distribute a square. You can't say that this is going to be x to the 4th plus 4. What you're going to have to do is you're going to have to write this out as repeated multiplication. Right? We have the same set of parentheses times itself twice. So if we FOIL this out on the right side of the equation, first times first is going to give us x to the 4th. Outer times outer is 2x squared. Inner times inner is 2x squared. Combine those and you're looking at 4x squared. And then last times last is going to give you a plus 4. On the other side, not really doing anything to it yet, just going to bring it straight down. If we're trying to solve an equation exactly, we're typically going to want to have it set equal to 0. So I'm going to move these two pieces over to the right side of the equation with the other three pieces so that we have a 0 on the left side of the equation. Now, if I move this x squared over to the other side, I'm going to have to subtract it, and that's going to leave me with 3x squared. Right, 4x squared minus x squared is 3x squared. And then if I move this 4, I'm going to have to subtract it, and basically this 4 and this 4 are going to cancel with each other. And then we just can't forget about the x to the 4th that doesn't have anything that combines with it, but still has to be part of the right side of that equation. This equation is now equal to 0. If you're trying to solve by hand in a calculus textbook problem, usually you're going to be able to solve by factoring eventually. We can now factor the right side of this equation. We have a common factor of x squared between the two terms. So if we take a common factor of x squared from this piece and this piece, we're going to be left with an x squared plus a 3. This is now a multiplication problem. The answer to the multiplication problem is 0. What we know is then either the first piece of the multiplication problem is 0 or the second piece of the multiplication problem or the second factor is 0. Square root of each side here gives you x equals 0. On this equation here, or in this equation here, we're going to subtract 3 first, and then we're going to have to take the square root to get rid of the exponent, and that's going to give us x equals. And when you take the square root to solve for an unknown, you do have to consider the two possible roots. And then when you do the square root of a negative, what you end up with is you end up with an imaginary value. So this is going to be plus or minus negative 1 times 3 under the root would allow us to rewrite it as I square root of 3. So how many real solutions does this equation have? Well, the only real solution is right here, x equals 0. This equation did have two imaginary solutions. Now in calculus, you're generally not going to worry about imaginary solutions, so those don't really impact us at all. If we wanted to go back to square one here, let's say we didn't know how to isolate x. If a calculator is in play, what I'm always an advocate of is if you take your calculator and you graph this equation for y1, and then you graph this second side of the equation for y2, so I'm basically putting the left side into the calculator as y1. and the right side in is y2, and I do already have that done, right? y1 equals this, and then y2 is equal to x squared plus 2. And I have some other stuff in there for the next example, but we won't need that just yet. I don't have those graphs on, so they won't appear yet. If you graph these, you want to know when y1 equals y2. y1 equals y2 at this point right here where the graphs seem to intersect. If you want to use the calculator to find that intersection, you're going to go into this calculate menu, which is above the trace key, so second trace. Intersect is option 5. You're going to want to hit enter on the two curves. So there's my first curve, and then it'll bounce me up to the second curve. So yes, these are the two curves that we're looking to find the intersection of. And then just give it a guess to try to get close. And what we end up with for our intersection is an x value of 0. So when x equals 0, those y values are equal to each other, and hence this equals this. So to solve an equation graphically, this is something you can always do as long as the calculator is in play. The one catch with calculus is the calculator is not always in play. In the next example, we will again use the calculator, and it's going to have the same set of directions. It's from the same problem set, same textbook. And in this case, it's a little bit tougher to try and isolate x. We could solve by hand, or we could solve exactly in the previous problem. This one, that's not going to really be the case. I can't combine this x with this x because I'd have to go inside this set of parentheses if I did that. I could get rid of this exponent and essentially get rid of the set of parentheses by raising both sides to the 3/2 power, but that's going to give me a set of parentheses here raised to the 3/2 power. So you're not really going to have any success in trying to isolate x and solving this exactly. So what I'm going to do is I'm going to graph, and it's actually going to be y3 and y4 on my calculator just because I didn't want to waste time to type these in on the video here, so I typed them in beforehand. So I'm going to shut off those previous two graphs and turn on the graph of this as y3. So y3 is going to be x squared minus 1 to the 2/3 power, and then the graph of y4 is going to be 2x plus 1. I'm only going to graph those two things. You will notice that I have this exponent in parentheses on the calculator. Anytime you're dealing with a scientific calculator, one of these TI-83s or 84s, and you're putting in a fraction, it's just good habit to get into to always put the fraction in parentheses. If we go ahead and graph at this point, we see our line that gets graphed here, and then we have this other weird looking graph for this function. These graphs do appear to equal each other. They do appear to cross at this location here, and we do want to know when this graph equals this graph. So if we go to find that intersection, so my first curve, so now I'm on that weird looking curve, now I'm on the line, give the calculator a guess to try to get close to that intersection point, and we get an x value of 0. So x equals 0 will make this equation true. The thing that is going to happen here, it seems like, is that it looks like although these pieces seem like they're parallel to each other, we know that this is not going to graph a line. So it's possible that the line that's right here is going to actually intersect the curve up here off the calculator screen somewhere. So what I'm going to do is I'm going to change my window settings so that I can see further up on the graph. I'm not going to use zoom in or zoom out. I'm just going to kick this up. Oops, I don't need to go further down. I'm just going to kick Y max, the distance I can see in the upward direction, up to 25. And it does seem like we are going to have another intersection point here. Now I'm going to take my graph or my window a little bit further to the right. So I'm going to change X max to something like 20. Not 210, but 20. Just so I have that intersection on the screen pretty well. So yeah, now there is definitely another intersection point right here. So I would repeat the same process one more time. Use the intersect feature from the calculate menu. First curve, so right now I'm on that weird graph. Now I'm on the line. I don't want to hit enter close to the first 0, the one or the intersection, the one that we've already found. I want to hit enter over here close to where this new intersection point is. So the calculator will think for a minute, and then it'll give you your other x value. So that's 9.534. So we get the x value of 9.534, and that's definitely an estimate. So I tried to, use the approximation symbol rather than the equal sign there. But this is how you can solve equations graphically. If a calculator is in play and you have a calculator that's capable of graphing this side of the equation, graphing this side of the equation, you can always graph those two equations and then find out where they intersect using the calculator to solve your equations.